Welcome to the third experiment of LT-SPICE software. In today's session, we are having the DC power supply. The aim of our experiment is to design and simulation of regulated power supply. All the electronic devices which requires the power supply. A DC power supply is nothing but to give a constant output voltage to its load. Depending on its design, the input source may be a DC voltage or the input voltage may be a AC mains. Usually DC power supply we are using for the low power applications. That means for the low voltage, low power, low current or aircraft specification, or regularly we are using for the batteries. Even in the solar panels which converts into DC power. First let us know what are the components of the DC power supply. There are 4 components of the DC power supply. The first one is transformer, second one is rectifier, third is filter and the fourth one is voltage regulator. First let us know the first one is transformer. From the transformer output we are feeding into the rectifier. The output of the transformer which is applying into the rectifier. From the rectifier output which is given to the filter. The filter output which is going to apply to the voltage regulator. The regulated output voltage which is applying to the load resistance. And this is the output voltage you are going to measure. This is the block diagram of a DC power supply. See, here in our circuit we are using the AC mains. So the AC mains you are having 230 volts as an input and 50 hertz of its frequency. So we will go step by step with the block diagram. First one is transformer. Transformer is a passive electronic device which is going to increase or decrease the input voltage. So there are 2 types of transformer. One is step up and the second one is step down. In the step up transformer, the output voltage is greater than the input voltage. So here the output voltage which is greater than the input voltage. In the step down transformer, the output voltage is less than the input voltage. So here you are having the AC supply, so you will be getting the same AC supply itself, but in our experiment we are using the step down transformer. That step down transformer, so the output voltage is less than the input voltage. This is the output of the transformer we are getting. This output of the transformer which is pure AC signal and the rectifier which converts AC into DC. You know that rectifier which converts AC into DC source, so the rectifier output will be pulsating DC. In the rectifier there are 3 types: half wave rectifier, center tapped full wave rectifier and the bridge rectifier. So in our experiment we are using the bridge rectifier. Why we are using bridge rectifier? The efficiency will be more compared to half wave and full wave rectifier. And this bridge rectifier, it will give the smoothen the output. The rectifier output means the ripple component which is available in the output of the bridge rectifier which is applying to the filter and it gives the pure DC source. From the filter which converts pulsating DC to the pure DC. In our experiment, we are using the capacitor as a filter component. In filter circuit, usually which removes the unwanted oscillations or it removes the ripple component of the bridge rectifier. So now this filter circuit, you are having the pure DC output, but this output you cannot directly apply to the load resistance. Because if suddenly changes in the input source, then the output voltage change, or if the load varies, then the output voltage it may varies. For that reason, we want the constant output voltage at this level For that reason we are using the voltage regulator. So in the voltage regulator we are using the IC voltage regulator. IC means integrated circuit. The voltage regulator which is already available in the market, which is in the IC form. All the discrete components which is fabricated in a single chip. So in the IC voltage regulator you are having the 3 terminal. So the 3 terminal is, one is in, one is ground and the third one is out. The unregulated output voltage of the filter circuit which is applying between the input terminal of the IC voltage regulator, the regulated output voltage you are going to apply to the load resistance. So now in the IC voltage regulator you are having 4 types. The first one is fixed positive voltage regulator, second one is fixed negative voltage regulator, third one is adjustable IC voltage regulator, fourth one is dual tracking IC voltage regulator. This is the RL you are having. First we will see what is fixed positive voltage regulator. The output voltage you will be getting fixed positive voltage here, usually 7/8 series which is available in the market. In this 2 terminal you will be getting the fixed positive supply. So the first 2 terminal, the first 2 digits which represents the positive supply and the next 2 digits which represents the voltage level. If we are writing here 0,5, you will be getting the plus positive supply. If we are writing, if you are using 7824, so you will be getting the 24 volts supply here. So in the market, in the 7/8 series, you can, which is available plus 5 volts to 24 volts. Now this is usually LM78 series. L means linear, M means monolithic. So I told already 7/8 series means fixed positive voltage. In the fixed negative voltage, what do you mean that? You are getting the negative output voltage here. Instead of 7/8 series, you will be having the 7/9 series, the output voltage will be negative. So the first 2 digits represents the negative supply and the last 2 digits represents the voltage level. So this will be the negative 24 volts you are, which is available at the output. In the adjustable IC regulator means you can adjust between 2 limits, means either from the 2 limits means one is minimum and to the maximum level you can vary the IC, you can vary the voltage level. So the voltage level may be plus 1.25 volts to 37 volts which is available in the market LM317 IC. So L means linear, M means monolithic. So LM37 which is available in the market for adjustable IC voltage regulator. In dual tracking IC voltage regulator means in this IC you are having both positive and negative power supply which is equally divided. So in our experiment we are having the fixed positive IC voltage regulator which is having the output of plus 12 volts. In the LT-SPICE software 7/8 series which is not available, in that case we are using LT1083 12 volt supply we are using. The LT means linear technology, we are having 12 volts positive supply. This is our experiment. This is the theory aspects I have told you, and we will go with the lab experiment how the simulation is working, and we will note down the plus 12 volts at the output of the voltage regulator. Welcome back to the practical session of DC power supply in LT Spice. Now we'll open LT Spice software. Go to new schematic. You have to simulate the DC power supply here, right? For that, first of all, you have to require a input supply. I have told you in theory that in our experiment, we require AC supply. Go to component, write down voltage, press OK, right click on it, go to advanced, select sine, you get various ranges. In the DC offset is equal to 0, amplitude is equal to 230 volts, frequency is 50 hertz, time delay is equal to 0, theta is equal to 0, phase angle is equal to 0, and the number of cycles are 1000. In the block diagram, I clearly explained that input AC supply which is connected to the transformer. In our experiment, we use step-down transformer. In the transformer, you are having two types of winding. One is primary and the second one is secondary. Input power supply has to connect to the transformer here. In LT Spice software, you don't get transformer directly. For that, you have to design a transformer here. How you will be designing? Actually, transformer works on the effect of mutual inductance. How the mutual inductance works? A transformer is a device made up of two or more inductors, one of which is powered by AC, inducing an AC voltage across the second inductor. That means, if two coils of wire are brought into close priority with each other so that the magnetic field from one link with the other, a voltage will be generated in the second coil as a result. That means you require two inductors here. Right click on it, select show phase dot, and the value should be 10 micro. Secondary also show phase dot, the value should be 100 nano. The primary of the transformer, you have to connect to the supply. Before that, I will take a series resistance. The value should be very small, 0.001. Connect the wire. Take ground terminal first. Wire it. Primary side connection is over. Now you have to connect the secondary of the transformer to the next circuit. What is the next circuit? So the transformer output is connected to the rectifier. In our experiment, we are using bridge type rectifier. In the bridge rectifier, we are having 4 diodes. So that 4 diodes you have to connect first. Bridge circuit I have connected. The transformer output connect to the one end of the diode circuit, other end of the transformer connect to the other side of the bridge rectifier. Zoom it, minimize it, it is easily clearly visible. Now in the block diagram which has explained that rectifier circuit output which has to be connected to the filter circuit. In our circuit we are using the capacitor filter. For that you have to connect one parallel resistance. The parallel resistance value should be 1K. Take capacitor filter. Take 470 micro. Take one ground terminal. Wire from the parallel resistance to the positive supply. Resistance other end to the ground. Capacitor other end to the ground. One end to the positive. Fine. We completed the filter circuit here. In the block diagram, output of the filter circuit which is directly connected to the voltage regulator. In our case, we use the IC voltage regulator. Zoom it. LT software means L means linear, T means technology. Linear technology software it is. In this software, so LT based IC regulators are more effective. In that case, I am taking LT1083 which is having 12 volts. Press OK. Ground to ground. IC voltage regulator connection is over. The regulator output is connected to the load. So, in our experiment we are using resistance is the load. We have to connect a load resistance. The range should be 10K. Output of the regulator to the one end of the resistance, other end of resistance to the ground. Now connection is over. So the mutual inductors you have connected here, that should be specified as a mutual inductance. The primary of the transformer is L1. Secondary of the transformer is L2 and the mutual inductance is 1. Keep it aside. Zoom it. Now go to simulate. Edit simulation command. In the transient mode, 0.5 is the stop time. Press OK. Keep it aside. Now connection part completed. Go to the run command. Check the AC supply is 230 volts or not. Yes, it is 230 volts. Again go to the run command. Check it out at the secondary transformer output. You are getting 22 volts. Yes, it is stepping down. Again go to the run command. You are checking here step by step. Output voltage means bridge rectifier output voltage you are checking. Yes, it is pulsating DC. Now you have to check the output should be at the voltage regulator. It should be a constant DC power supply. 12 volts supply fixed to positive. 12 volt supply you are getting here at the output of the IC voltage regulator. So like this you have to work in your system. Definitely you will be getting the output. Thank you.